Thank you. Thanks so much for having me. Sorry about the last, some fonts didn't transfer and things were getting cut off. So, in fact, they still are. So, very glad to be here. In case there's any tweeting that you'd like to do, these are the key identifiers for me personally and for my team. So I work at the New York Public Library, and I run a department called Digital Library and Labs. And what we basically do is we're looking at the entire digital life cycle of our collections. And by collections, I'm mostly talking about the kind of rare and unique materials the library's collected over the years, less focused on the secondary materials in our research collections, more the kind of the archives and special and rare material. Our team works on the digitization of collections, the description of collections so they can really talk to the web, usually at the item level, ideally, and then the use, engagement with, and enrichment of collections. And by enrichment, you'll see what I'm talking about more later, but sort of adding new information or mining new information from the collections once they've kind of become digital. So in other words, we're kind of looking at asking the question, what happens after you digitize? What is the story that begins then? So digitize not as the end goal, but as sort of the beginning of a new kind of internet networked existence for our collections. And we have a lot of material. We're in a kind of a massive data migration, moving our kind of knowledge base into the networked environment. We're just barely scratching the surface at the moment, but what we're focusing on right now is how to kind of prioritize, move things that have high engagement value, high research value, and model processes that can get more efficient and more over time to kind of process material more quickly. So the library, as you can imagine, is undergoing a profound transformation right now, moving from stacks to server racks. And underlying all this kind of is an animating idea for our work that's looking at the institution in a different way, looking at not as kind of a closed repository or sanctuary, but more as a node on a network. So how do we get our collections talking to other collections, to other institutions, to other kinds of information? For all that, it's not some glorious rapture where we kind of lose our sense of place. We're still an urban library. We're still rooted in a city, in a very specific place, with a very specific set of concerns and a very specific history. And so the story I'm going to tell you now is around a particular type of collection, maps, and how we're trying to get these maps talking to the places that they refer to, typically in the past tense. So as an example, this street corner in the West Village, you wouldn't know walking by it that this corner of 6th Avenue and 11th Street was once the old Grapevine Tavern, which is where, through the grapevine, the expression comes from. It was sort of the local gossip mill, a place where artists, politicians, bankers would kind of gather, and there was actually an old grapevine growing on its side, which kind of superseded the original name. And this was the main information provider of the neighborhood before the New York Public Library set up neighborhood branches there. So this is a vanished place that you wouldn't immediately have access to or knowledge of in walking through those streetscapes. Here too, this in Soho, this stretch of Broadway right at Prince Street, you wouldn't know this, but this was actually the site of Niblo's Theater, which was actually, it is generally agreed upon, the site of the production of the first American musical, or like book-based musical, The Black Crook, which is a kind of a fantastical story of witchcraft and sorcery. And there actually was a garden. That was sort of the entrance was on Broadway, went back to a much larger complex. And the very place that I work is a kind of a great example of this kind of layer cake of history. This is a view of the New York Public Library more or less today. Here it is in the 30s. And this actually, before this was built in 1911 or completed, was the city's main water source. It was the Croton Distributing Reservoir. And actually, my office, which is a more modern insertion into an old formerly open air courtyard, you can still see some of the foundation of that original reservoir. So this kind of time travel, this kind of drilling down through the layers is on our minds a lot, and looking at how we can pull from some of our great collection strengths, among them being New York City history, and see how we can get these materials talking to other information spaces and actually make these more than just kind of like act on this impulse of connecting these dots. Also on this footprint, behind the library is the gorgeous Bryant Park. This used to be the site of the New York City Crystal Palace, which was kind of at its time in the mid-19th century a kind of a global exposition space that then tragically burned down 3 years after it was erected. So where do we find the hooks? How do we start to join these pieces of information? Looking at the maps, the kind of map that is most promising and that we've focused most of our effort on are these atlases produced by insurance companies, largely in the 19th century, but going into the early 20th century. These provide building level detail of the city over different time periods, and they were created with incredible accuracy and fastidiousness because they were used to calculate property values to manage risk. Things were burning down all the time, and these maps provided keys. They were full of data, color codings and other markings that gave you information about what the building was made of, what kind of risk it was, what its use type was, residential versus commercial, what kind of things were being manufactured there, were they particularly flammable. And so you can see here, this footprint is the kind of the locus of the stories I was just telling now about and there is the footprint of the Crystal Palace, that large kind of circular blob, and next to it the reservoir. So that's where I work in that footprint, but of course it's inhabited by very different places. So we've been digitizing these maps for a number of years, and we put them online as images of old maps, and that's nice. I mean, formerly you would have to come on site to look at this in person, and now you can go to a web page and see an image of the map, and it has a bit of descriptive metadata, usually not particularly helpful. It will tell you the bounding streets, as you can see, but it's not going to tell you the interior streets. So it doesn't, if you're looking, for those accustomed to a kind of a very fluid geographic search, it's going to frustrate that. You have to kind of know how to query around the edges, literally, of map plates, because maps have for a long time been stored in codex form. But this is clearly a step forward. But how do we turn the maps into data? How do we create a new collection that is essentially a data set, a set of APIs, an ontology, a set of hooks of places through time that other information can be aggregated against? This is being done in the kind of contemporary space. The New York City has a data portal, a government data portal, as do an increasing number of cities now. There's a movement opening up government information. And there is a building footprint file of today's city. They even have some basic kind of visualization tools where you can map these things in kind of like a fusion table within their website, and you can start to look at the buildings of today's city, these parcel and lot data. But what we're really looking at, and what we see kind of trapped in these maps in pixels once they've been digitized, is kind of a revision history of that building footprint file, the kind of the change log of the city's built environment over a number of centuries. So how do we get these maps to be queryable in the way that we have come to expect of maps? So again, as I said, it begins with digitization, imaging the collections. This is where you have to begin. And here's an image of a page of one of these insurance atlases. They're very lovely. And they vary a lot. Sometimes revisions were a new section of a page pasted over. There's wear and tear, there's different kind of colors, slightly variations of the colors of paint, but the data is there. Next comes a process that's called georectification or warping. And a number of years back, we worked with some collaborators kind of in the OpenStreetMap community to build a tool suite called Map Warper, which is a set of OpenGIS tools that can be found elsewhere in like ArcGIS, but are an open source stack and something that we built for the use of our staff and then also the public to kind of help with this work. And so it's basically a matching of old maps and contemporary maps. And with urban maps that were produced with this kind of high level of detail, it actually works quite well. You can find one-to-one correspondences, set up a number of control points, and kind of rubber sheet them together. And so you start to look at the maps in their geographic context. This map, once it's been, all the kind of non-map material from the page has been stripped away and cropped away, you have a map that is actually a spatial asset. It can be viewed in a spatial context. So we've taken a big step forward there. We've gone from pixel space to geospace. Then you can start to stitch the leaves together. And so you start to see a pretty stunning remediation of a collection. Here is an 1854 street atlas describing the very lower tip of Manhattan at the Battery up to 42nd Street, right at the top of that sheet I showed you with the Crystal Palace and the reservoir. And it's stitched together as a quilt laid over the island of Manhattan. So these historical documents are starting to kind of take a new form that is more in sync with the kind of information that they represent. And this is now a new kind of library collection. These can be exported from the MapWarper site as layers, as KML files. So you can just open it in Google Earth and start playing around and playing with transparencies. So there's a pretty low barrier to accessing these collections. Now, so the map, the atlas, is now a digital asset and a spatially aware asset. But the buildings are still locked in those sheets. So the next step is vectorization, or kind of tracing features from these maps. And there's a tool in the MapWarper suite it works, but it's rather cumbersome and labor intensive. And it involves literally tracing polygons over footprints and then transcribing a bunch of attributes that are informed by the key of the map that tell you what the color codings mean, and then other information that you can read very readily, like the addresses and the street names. So you can transcribe these, they get associated with a shapefile, and then suddenly you have a new spatial asset, a very granular one that's associated with this larger map layer. And these too become collections that can be exported and visualized. So this is the building file, almost complete at this point, at this export, of that 1854 street atlas. And this also can be exported and looked at in things like Google Earth. It can be mapped in fusion tables. So there, a similar view that I looked at from the New York City's contemporary data portal, here is the 1854 layer, and you can see right there the residential neighborhood that is now in the on-ramp to the Brooklyn Bridge. So you can start to see some of that then and now. But what's really interesting, why do this? For urban history and other disciplines, there is inherent value in having that changelog and just having the building files as a data set in itself. But what gets really interesting in kind of reimagining a library is how these buildings can become, and these places can become hooks, can essentially turn the city into a kind of a catalog interface. And we have started to prototype basically a database of these historical locations, harvested from the maps and other sources. It's what is often called a gazetteer. And so this is actually, from our very rough prototype of this, the record for that Niblo's Theater location, and there you see its shapefile extracted from a map. And this is the thing that we can start eventually to hook other collections to. So you could eventually find newspaper archives about this location, original playbills of this musical I mentioned, The Black Crook, and here's a kind of a bit player from the production. You could even start to get electronic editions of the libretto and text that our performing arts curators have produced. So that's what we're kind of imagining. That's why we want to do this, to see if the city can really be turned into an interface where you can sort of add a time slider to the map and then find related materials based on the time and place. And we have, again, a lot of materials that we would like to associate with. There's old city directories, archival correspondence and documents, ledgers, newspapers, image collections, and so on and so forth, proto-street views, et cetera. So that's all why we want to do this vectorization process. But as I said, it's incredibly slow. And in approximately 3 years, with intermittent outreach efforts, because this is largely done by volunteers, we've gotten about 125,000 shapefiles extracted from 3 atlases. Sorry, this is a font casualty. It says atlases below there. That sounds like a lot, but it's really barely scratching the surface in the kind of the entire archive that we have. So we've been asking in our team, is there a way to automate this process? Is this something really that we have to get handcrafted, artisanal, small batch kind of data production, or can we start to put computers to work to do this? So this is a picture of a member of my team, Maurizio Giraldo, who built all the applications I'm going to be showing you and the processes I'm going to be showing you from here on out. And this is actually him during a map hackathon we hosted about 1.5 years ago now, where he was actually in that picture just starting to crack the problem or address the problem that I will now walk you through how we've approached. And just as a side note, the building files, this is our geospatial librarian and curator from the map division, looking very model-like there. And the shirt he's wearing is actually the 100 largest buildings from the 1854 street atlas. It's kind of unapologetically aesthetic treatment of the data. And we're interested in even in playful ways that we can engage the public with merchandise and with other things that can sort of tell the story of this transformation of the collection. So just as a side note. So he was looking at one iteration later, about 3 or 4 years later, an atlas that extends from the Battery to the lower portions of Central Park from around 1857 to 1862. And we're looking at 159 map sheets here in this initial experiment. So scripted together a bunch of open source processes, scriptable tools to kind of develop an image processing workflow that could read these shapes out of the maps, that could automatically extract the buildings. And the basic guidelines that Maurizio applied were, because there's a lot of shapes on these maps, so how do you find the ones that are the buildings? He applied some basic rules. They're completely enclosed by black lines. Oh, this might be a font casualty. Dash lines are not walls. There's a kind of size thresholds, small and large. And finally, well, I may actually even forgetting what the fifth one is. The point is, through stringing together this workflow, he got some pretty impressive results. So this is the automatic output on one map sheet. By kind of operating within those, not too small to be a building, not too large to be a building, ignoring the streets, which are polygons in a given sheet. And this is what we produce. So this looks promising. This looks like we're onto something here. And what we're essentially have built is sort of like an OCR, or optical character recognition for maps, a way to kind of read the shapes and turn them into machine-readable data. But big surprise, it's not perfect. It doesn't catch everything, and there's a lot of junk in there. In fact, right here you can see one kind of issue that we come across is there's false negatives. There's like a whole row, a block that it basically missed for some reason or another, maybe because there was a little gap in the lines or some discoloration or imperfection in the page. But we're looking at something that looks pretty good, something we can work with. So knowing that the vectorizer tool can get this output overnight with a whole series of atlases, and probably much faster on a more powerful computer or working in parallel, we can crunch through a lot of maps very quickly. So then how do we deal with that quality control? So this brings the fourth and final step of this journey that I'm describing, this digital life cycle, and it is crowdsourcing. And we're operating on the kind of the precept of Clay Shirky's cognitive surplus, that there's roughly a third of the human kind of brain cycle that is not spent sleeping and not spent working. What is that applied to? Is it applied to consumption or some kind of production? And a lot of kind of collaborative knowledge efforts have tapped into that cognitive surplus to produce things like Wikipedia, open source software projects. A more vivid way of I think of illustrating this is this frightening statistic. It's even a couple years old, that every day. There's 300, every day or every hour, 16 years, human life years are expended playing Angry Birds. And this may have gone up. And then apply this to other games. So what if we could tap into even a sliver of this kind of cognitive surplus, this spare time, to invite the public to help us crunch these large piles of data? And we've been doing this with other collections. We've been doing it around transcription projects. We have a very successful project around our historical menu collection. We're asking people to create a culinary database by transcribing the dishes and prices out of old menus. It's produced nearly 1.3 million dishes, and they're available via an API and data exports. We're prototyping a similar project around theater playbills to create kind of a knowledge graph of performance history from old playbills that the Performing Arts Library in our system has been collecting for decades. So the way we did this for maps, and for these maps in particular, sorry about the font change there, is our project called Building Inspector. So buildinginspector.mypl.org. And if the vectorizer process is kind of like the OCR for maps, for kind of urban building level maps, this tool is sort of like the reCAPTCHA, the kind of sneaky little tool that's woven into authentication interfaces that helps you prove that you're not a bot, and also gets some validation of OCR text processing for Google, which is why they bought this company. So this is kind of the reCAPTCHA for our vectorization process. And the basic interface that we launched with is a simple 3 questions around a given polygon. Is it right? Is it completely wrong? Or is it in the ballpark but needs fixing? And I'm going to show you the kind of mobile view. It's a responsive website, so this scales down very, very elegantly to a small screen. You still need to have a network connection. And this is the kind of fluidity, almost game-like repetition that it involves. So this is just, you can reframe the map a little bit, and we're just asking you, does it look right? Is it totally wrong, or does it need a fix? It also allows you to kind of view your progress and start seeing the bigger picture. And so there are obviously quality control concerns inherent in this process. Are we just going to trust what one person's verification of this polygon, of this vectorization output? And the answer is no. We're modeling a process out of the citizen sciences, particularly out of the Zooniverse project that some of you may have seen, where they put the same task in front of multiple users and kind of let a consensus bubble up from below just through scale of participation. So there are kind of some mathematical thresholds. Basically, if 3 or more users agree, it's going to be kind of trusted. If there's not agreement, it'll kind of stay in the queue and still get more inputs. If it's really kind of a split decision, it'll go into another queue that we're going to deal with later and haven't figured out yet. But by and large, this does kind of shake out very well. And here you can see this is a view of a current sheet, and everything that has received consensus by the crowd is green. The yellows are still are the consensus fixes. And then actually you can't see in view here any reds, which would be the no's, all the consensus no's. So that was the version 1 that we launched last fall, just on is this polygon right or not. Version 2, we started to kind of develop out the workflow here. So from the checking task, a consensus yes, we'll send it into 2 new queues where we're going to ask for new kinds of data from the maps. We're going to ask you to type in the address, and we're going to ask you to kind of identify the color. And the color is significant, again, because it gives us information about the materials with which the building was constructed. Consensus fixes will go into a fixing tool. And then, once they've reached consensus or been fixed, they will go into this yes queue and go into these 2 other workflows. Footprints marked as no are, we bid goodbye to them. And so we relaunched this spring with 3 new tasks that start to animate this workflow. So here is the fixing task. It's just a polygon editor, and it actually works well, very, very fluidly in this small screen. We're really trying with this project to also set a new standard in interaction design for libraries. The expectations of the public are rather low as to the technical products and digital designs that are output by public institutions, especially libraries. And we've been really trying to kind of change that expectation and kind of surprise people with things that are elegant, fluid, and really beautifully interactive, and kind of let the materials speak for themselves. So that's the polygon fixer. The address tool looks like this. You just type an address, and you click an address and type it, and just all of it with sort of like a game-like flow that you can get into. And this is the color checker. Unfortunately, not very friendly to the colorblind, but for those who can, this is another valuable piece of information that we're extracting from the maps. And there's an option for 2 colors. So you might be wondering, will people actually do this? Is this actually, it all looks very nice. We've mapped out a nice workflow there, but is it really going to work? So far, with actually fairly modest participation, because the library is going through kind of a big web UX alignment that's going to better surface projects like these. We've been doing these kind of as satellite projects and having to build our audiences for them kind of independently. They're branded by the library, they're embraced by the library, but they're not very easily discoverable via the library's websites, which get a lot of traffic. So given those challenges, we've still gotten quite respectable participation and a really ecstatic public response from those who participated. So just to give a little bit of the kind of sentiment from some of the tweets that we've been getting. So people seem to really dig this. And maybe we haven't bested Angry Birds, but someone has actually compared us to Flappy Bird. So I take that to be incredibly encouraging. And so far, we have logged, as of yesterday, over 845,000 inspections. And again, with pretty modest web traffic in the tens of thousands, and we over many months. And so as we kind of refine this workflow and kind of really kind of keep trying to push the envelope with interaction design on these projects, to kind of let the materials speak for themselves and then just have that task be very clear, very in focus, and very repeatable, very even pleasant and maybe even addicting to do. We think that this has a great potential to scale as it gets woven into to the library's kind of main kind of program initiatives. And that is the aim. So these crowdsourcing initiatives, we've been kind of proofing them out for the last few years, and we hope to kind of scale these out in the years to come. And the dream then being, of course, coming back to my initial story, that we'll start to have these hooks, have a very well-populated historical data set for the city, an ontology, a set of hooks that we can start aggregating other materials around. So the library can really kind of become a time machine that can be accessed programmatically or even in a casual mobile interface, browsing the city and wondering what was in that building, what was on this place many years ago. And so up next for the project, we'd like to figure out an offline mode. So this could be done in the New York City subway. Our patron base is very subway oriented, and there isn't reliable connectivity in the subway at this point. And so being able to cache maps, check out a set, and crunch that on the subway, and then check it back in will be really, I think, put us in a kind of more competitive position to the Flappy Birds and Angry Birds of this world. So that's my story, and thank you for your attention.